Bismillahirrahmanirrahim. This is teacher Iman explaining solving equations from the second degree in complex number set. The first lesson is about finding the roots or solutions or zeros of an equation from the second degree. The first note is talking about solving a quadratic equation by using quadratic formula like z equals negative b plus or minus square root of b squared minus 4ac over 2a. And this quadratic formula can be used from the equation of az squared plus bz plus c equal to 0 by being sure this equation is equal to 0 before you're gonna have the values of a and b and c. So please be sure before you're gonna start that the equation is equal to 0. And this equation or this quadratic formula can be used by taking care about delta, and delta is that discriminant which is under the root, which is b squared minus 4ac, because it has three cases. The first case is if a delta bigger than 0, that means the equation has two different real solutions. Two different real solutions. And if delta is equal to 0, that means the equation has two equal or repeated real solutions. Repeated real solutions. And the last case, which is the most important in our lesson for today, if delta is smaller than 0, this means it's a negative. So it has no real solution. No real means imaginary. That means the equation has two different complex numbers. Complex numbers or solutions. Because there is a square root of negative, as you know. And the square root of negative always can be changed to I. Now, before we're gonna start and having some examples, we can read some notes. The first note is f. The quadratic equation contains both z and z dash. Then we can assume that z equals to x plus yi from the algebraic form, and z dash, which is the conjugate of it, is equals to x minus yi by changing the sign of the imaginary part. Then you can equal them, equal real part from the left side with real part and imaginary with imaginary, like this. And that can help you to find the values of x and y, and this is the way to solve the equation. The second note is saying if you have b equal to 0 in the equation of a z squared plus bz plus c equal to 0, that means this b with z will be cancelled, and you can get a z squared plus c equal to 0. You can solve it by two ways. The first way is factorizing them by difference between two squares. Difference between two squares. Or you can move this c to the other side, and that will change its sign from positive to negative to be az squared equals to minus c. Then divide both sides by a to get z squared equals negative c over a. Finally, you can take a square root for both sides And that will give you two answers, plus and minus square root of negative c over a, and negative under the root will make it I. So the last answer will be a complex number, which is gonna be exactly like this. Let's start now the first question, and before we can read the question, write true T or for the true statement and false for the false one. The first question is the equation z squared plus 9 equal to 0 has two solutions in complex number c that are plus and minus 3i. The first way to solve, which is factorizing. So I can factorize them by this way. Z squared plus 9 equal to 0 can be factorized by writing z squared plus 9 minus, it's better to write it as minus 9i squared. That means I squared is negative times a negative is positive, and that be used as difference between two squares. So you can factorize it as z minus 3i, then z plus 3i equal to 0. Either or, z minus 3i equal to 0, then move this 3i to the other side to be positive, and that will make it as z equals positive 3i. Or you can have the other bracket, which is z plus 3i equal to 0, which is the other factor, and move again 3i to the other side to be positive. That will make it as z equals negative 3i. So you will have two solutions, which are z equals plus and minus 3i. Other way to solve, you can do not factorize them. You can move to the other side from the beginning, and this way will be easier, like this exactly. Z squared plus 9 equal to 0. If you will move this 9 to the other side, that will change its sign from positive to negative, and take a square root for both sides. That will give you always plus and minus for any quadratic equation for minus 9, and that will make z equals to plus and minus 3i, and which is the same solution for the first way. So that will make our answer true. So this is a true. Let's go to number 2. We can see that the equation z squared plus 16 equal to 0 has two solutions in C that are plus and minus 4. If you will solve them, you will repeat what we did before, but I will use one of the solutions, which is moving to the other side. Z squared equals negative 16. Take a square root for both sides. You can get plus and minus and having I. So the answer is z equals plus and minus 4i, and you can see there's I here, so it will be false finally. In number 3, the two roots of the equation z squared plus 2z plus 3 equal to 0 are negative 1 plus and minus root of 2i can be solved easily by checking that the quadratic equation and be sure that this quadratic equation equal to 0 before you're gonna start. And then think about the product of a 3 and the sum of 2 here and there, if you can factorize them. and you can see that you can't factorize them. So you are going to think about using quadratic formula. And this quadratic formula needs from you to be sure about the delta. So z will be equals to negative b plus or minus square root of b squared minus 4ac divided by 2a. How much is a and b and c? Let's think about them. A is 1 and b is 2 and c is a 3 from the equation. Now let's replace them. Z equals negative 2 plus and minus square root of 2 squared, which is 4, minus 4 times 1 times 3. Close your bracket and divide all by 2 times 1. Try to find z easily. Negative 2 plus and minus square root of 4 minus 12 divided by 2. After subtracting them, you can get negative 8 divided by 2. Then you can get, after simplifying this 8 to 4 times 2, as plus and minus 2 root of 2. And this negative can be changed to I divided by 2. Now you can split negative 2 here and there to simplify your work. To get z equals negative 1 plus and minus root of 2i, which is the same as his solution. So that will make it true. In number 4, 1 plus 2i is one of the solutions of the equation z squared plus 2z dash plus 1 equal to 0. Because he said it is one of the solutions, that means you are going to replace. So he give you the value of z, which is 1 plus 2i. You can substitute it in the equation, exactly like this. 1 plus 2i all squared plus 2 times 1 minus 2i, and we change the sign of the imaginary part because it is a conjugate, plus 1 equals to 0. I will expand this perfect square by using this rule, which is the perfect square rule. A plus bi all square can be expanded easily by using a square minus b square for the real part, and plus always between real and imaginary, 2 times the real, then the imaginary part. So if you're gonna use it, you can get 1 square minus 2 squares, which is 4, as a real part, plus always between the real and the imaginary, you can get 2 times 1 times 2i. Then you need to expand the bracket by multiplying 2 here and there. You can get plus 2 minus 4i plus 1 equals to 0. Now you have to be sure that the left side, when you add it, you will get 0 to make the left side equal to the right side, and that will make your statement true. 1 minus 4 is negative 3 plus 4i plus 2 minus 4i plus 1 equals to 0. When adding like terms, you can get that 4i and negative 4i will be 0 because they have different signs, and negative 3 plus 2 plus 1 also will be 0. So that will make the left side is equal to the 0 and the right side, and that will make your answer true now. we can go to question 5, the solution of the set of the quadratic equation z squared plus 7iz plus 6 equal to 0 is 6i and I. To solve it, you need to use a quadratic formula, but be sure that your equation is equals to 0 always before you're going to use the quadratic formula. How much is A in the equation? It's 1, and B, it is 7i, and C, it is negative 6, and be sure about negatives and I. Now we can use the quadratic formula, which is z equals negative 7i plus and minus square root of 7i squared gives 49i squared, which is negative 49, minus 4 times a times c, all under the root, divided by 2 times a. Z equals negative 7i plus and minus square root of negative 49 and plus 24 divided by all 2. When you subtract negative 49 plus 24, you can get negative 25 divided by 2. Now, z will have two solutions, which are negative 7i plus and minus 5i according to the quadratic, to the complex number, divided by 2. Now you will have two solutions. Either you're going to add them or subtract them. So z1 equals negative 7i plus 5i divided by 2. After adding or subtracting them by taking the different or the biggest sign and subtract them, you can get negative 2i divided by 2, and that will make the last answer is negative I. Or z2 will be negative 7i minus 5i divided by 2. They have the same sign, so add them and keep the negative by making negative 12i divided by 2. So z2 equals negative 6i. Compare now your solution and the solution that they have. You can see that the negative is not there. The negative is not there. So that will make the solution false, or the statement false. Thank you very much.